Right, well, good afternoon, everyone. My name is Paul Barnfather. Apologies for my late arrival today. It was apparently caused by trespassers on the line, but I'm here now, and yep, we're on time, and I'm not going to make you late for lunch, so hopefully that's good news. I'm head of asset investment management at EA Technology. My background is I've spent all of my career working with high voltage equipment, but as a specifier and a designer. So I spend most of my time thinking about what things should be on the system, but very little time actually using them, and that probably makes me part of the problem. So hopefully you can. What I'm going to do is show you a little bit, share with you a little bit about how asset management processes work, what asset management is, and give you an example of how, when asset management is done correctly, it can bring about huge change. And what I hope is that with the right approach, asset management can bring about a similar change in safety as well. So moving on, spacebar. Right, I think you've already seen this diagram, which shows how the various functions link with the outside world, whether it's regulation, customer demands, and the field operations are stuck there in the middle alongside asset management. Obviously, there are changes occurring in the regulatory framework, and the regulators always are pushing for better performance with less money, legislation changes. So we've got onerous regulation on one side. And on the other side, increasingly in the energy business, especially, we've got some fairly disruptive change happening. People are using electrical networks for different things in different ways. And those combine to put quite a lot of pressure on the asset management functions to kind of bridge those two changes. So what I want to do is talk to you about how that works in the world of asset management, and whether there's anything we can do to improve safety culture along the way. Okay. The world of asset management is defined by a standard, ISO 55000. Hopefully you're familiar with it. If you're not, I don't really recommend reading it. It's not a particularly exciting read, but I'll try and summarize it in about a minute, because it's not a complicated standard. It is about achieving organizational goals. That's the headline. It's not about achieving anything specific like safe operation. It's only about safe operation if that is one of the organization's goals. So it's absolutely crucial for ISO 55000 that what a company is trying to do is clearly articulated. And hopefully in all of your cases, safety is a very high priority. Right. I'll go through the headlines and just translate them. It talks about organizational context. Basically, why are we here? What is the company for? That's the first thing that it looks for. Next, who's in charge? Who's going to lead this company to achieve its objectives? What are we going to do? That's the planning department. Who can help me? Support and resources. How are we going to do it? This is where operations come in. Exactly how are we going to achieve these goals? How well did I do? This is audit and review. Seeing, well, did things go well? And most importantly of all, how can we do a better job next time? Does that look familiar to you? Because it should be exactly the same as health and safety thinking as well. It's the same thought processes that go into asset management as in health and safety, just the language is a little different. But asset management requires you to have a documented approach to all of those things. Have you clearly stated what the company is trying to achieve? Do we know who's in charge? Do we know what we're going to do, and who's going to help me? How should I do it? And did we do it well? And how can I do a better job next time? So that's asset management, nothing too complicated. What makes it difficult, particularly in the energy industry at the moment, is that there are changes happening. It works very well to have a nice, stable, documented asset management system when things aren't changing. The moment we've got a radical transformation occurring in how people use our networks, energy networks. Now that hasn't translated into new assets. The assets are still the same old ones we've always had. And yet now we've got more dependence on heat, which is on the electrical network for heat, which is forecast to change. And all the hype around electrical cars is indicating that your transport might be dependent on electrical networks too. So people's expectations of those networks will change, and it will change much quicker than we can change the assets. So that's the first challenge. Secondly, the way in which electrical networks are evolving are moving from, they're not so much paid for being good asset owners and good stewards of assets, which is the sort of the regime that I've been trained in. Now you get less reward for just owning and looking after the assets, and it looks like you're going to get paid for providing services that people value. Well, that's fine, but that requires quite a different mindset because the stewardship idea isn't as prevalent then. And if you're not getting paid for stewardship, what happens to that stewardship? So those are some challenges. On the other side, there are some technologies to help us in this new world. Certainly, active assets as opposed to passive assets can detect faults, catch them before they start. If they do detect a fault, they can route the electricity in a different way and have the power back on before you know it. So there's less operational involvement there in keeping the lights on. Now, from a safety point of view, that's a good thing because working safely when the pressure's on and when time is pressing is never good. So automation and self-healing networks are a useful development. The other conceptual challenge is that we're now delivering these services in the electrical industry not necessarily with physical assets. Sometimes we're paying somebody to provide a service, to provide voltage support, to provide frequency support. Well, the loss of that service is, in a lot of ways, similar to losing an asset, but it's not a thing that we can look after. It's a contract. It's an entity that could go bankrupt. And yet effectively they're contributing the same as physical assets. So bringing that thinking into our physical asset mentality, it's a bit of a change. And hopefully to support us, the modern devices are very chatty. They produce data all the time, gigabytes, terabytes of data. We've got data coming in everywhere. How you use that and what you use that for is a bit of a challenge. And particularly when things are starting to evolve in real time. The net effect of this is that those circles start to go around and round and much, much faster than they did before. Now, the definition earlier on about asset management was its documented framework. Well, it's very difficult to maintain a documented framework in it when things are changing so rapidly. So I just want to show you, so some big challenges coming up. How does asset management say that you cope with this? Well, some fundamentals. Let's step away from all of this exciting technology. Asset management begins very early in the process. There's a transformer. It's not been built yet. This is what the planner sees. He's thinking that one day we might need a transformer, maybe in 5 years' time. It's little more than a concept at this stage, but the asset management process has already begun way before the thing is commissioned. We then go to specification, procurement, and a lot of detailed decisions are made, again, long before the asset's been commissioned, that are going to be locked into that asset for 40 years. Eventually, if everything goes right, the asset arrives, and that's hopefully you get what you pay for and it continues to work, and the operations activity will be centered around that, and hopefully it can be used and operated safely. And what we do is over 30, 40, 50, 60, 70 years, we rely on operations to make sure that things like that don't happen. So that's the sort of the life cycle view of the asset. So you've got all of these stages from concept to design to commissioning to operation to failure avoidance, and maintenance and operations do that. And how do you join all of those up so that they work effectively? Because if each one of those is a separate department, they're going to find it very difficult to be successful. So the step of design, specify, procure, install, operate, maintain, and dispose, that's asset management. And the idea is to make sure that those all join up in a nice, coherent way so that we can keep the costs down and keep the reliability up. So it requires quite a high-level view. Notice it's not saying, it's all down to operations to deal with that. It's the full end-to-end process. If we make mistakes at the design stage, if we make mistakes at the specification stage, that is going to cause operational costs, hazards, and unreliability in the operate and maintain stage. So, I'm sure you're aware of this, that planners always make mistakes. And the idea behind the asset management thinking is how can we bring that thinking earlier into the stage so we design out some of these safety problems. That's the hope, anyway. Right. I'm going to share with you an example now of a company that have used asset management techniques very effectively. You may be aware of them, you may not. It's not a safety example, but what it is, it's an example of how asset management thinking, using this end-to-end approach, absolutely transformed the way a company worked in a way that I wouldn't have thought was possible had they not already done it. But this is Singapore Power, a company that delivers power at about 15 pence a kilowatt, so probably pretty much the same as what you pay here. And their SAIDI, the System Average Interruption Duration Index, is 0.74. It's about 45 seconds, which means that the average customer can expect to lose about 45 seconds of supply per year, which is, by all accounts, pretty good. They have managed to build basically one of the world's safest electricity networks. And there was a comment earlier on about looking at trying to learn from good practice as opposed to things that have gone wrong. I thought I might share with you just a very brief insight into how they achieved that, because it might be safe to, you might assume that, well, they've always had a brand new network and it's always been fine. We'll have a look at that. But basically, they're pretty much a leader in terms of reliability and asset failures. I'll just put that in context very briefly on a map for you. That's Singapore. Here in London, pay about 15 pence a kilowatt hour. The SAIDI is about 30 minutes. Now, you're probably absolutely fine with the supply reliability in London. I'm not saying that London is somehow worse than Singapore. If that is appropriate for London, fine. If it's not, it needs to improve. But maybe 30 is absolutely right. But for Singapore Power, their absolute number one priority was supply reliability. A lot of their industry and a lot of their economy is dependent on high-value manufacturing, and it was fundamental for them that they had an extremely reliable source of power. So 0.74 is vastly better. 45 seconds versus 30 minutes, that's a huge difference. Somewhere else in the world, again, not judging success or failure, because in local terms this might be fine. In Mumbai, the electricity is cheaper. You'd expect that. It's a rapidly developing nation. They pay about 7 pence a kilowatt hour. Power goes off for about twice as long. I guess that's probably okay if you're getting it for half as much. Again, I'm not saying what's right. The important thing here is the individual companies have been very clear about what the local needs were, and they've gone for that. So that's just Mumbai. Hong Kong, interestingly, cheaper and more reliable, cheaper and better. Yeah, it's something we're hearing from China all the time these days, isn't it? Cheaper and better than what we do here. So the electricity is cheaper and it's very reliable. It's a factor of 10 more reliable in Hong Kong. Again, it's a completely unfair comparison. I get that. The topology of these networks is very different. But at the end of the day, the customers don't really care, and that's who's paying. At the end, the customers are receiving this service for this kind of money. US, I don't know if we've got any Americans in the audience, a very different approach to electrical reliability. Yes, it's a little cheaper. The supply performance is pretty awful. London would not be happy if it was going off on an average nearly 2 hours a year. I guess they're happy, I don't know, but it does seem very strange. I find it hard to understand how that could be regarded as a successful service delivery, but maybe it's fine. Anyway, who am I to judge? But that just puts Singapore Power's achievement in context. It's off the scale. So let's have a look, see what they did. Well, if we go back 20 years ago, their SAIDI was around 30, same as London. So it wasn't that different to here. Pretty standard supply reliability for a heavily populated, very dense, reasonably new network. So what did they do? Well, they changed how they ran the network. They didn't go out and buy a brand new network with a whole bunch of new assets, which is sometimes what's associated with asset management. Let's get new ones. They just changed how they operated it, and they put in some automation, closed all the rings, made it self-restore. And that led to a 10-fold reduction in the supply interruption durations. Now, that's a big achievement. They already, at the turn of the century, were a factor of 10 better than we are here, just through a change in operating philosophy. Now, that obviously had to impact on the specification, the operations, the maintenance, everything. But it was a change of operating philosophy that had a huge effect. They weren't happy with that. They kept going. They then started to introduce online monitoring, condition assessment, really intensive analysis of every single asset to make sure there's absolutely nothing wrong with it. Any doubt, replace it, is actually their philosophy. But what they were doing is, rather than doing maintenance, what's interesting in this scenario is they actually do zero maintenance, as I would call it maintenance. They do not do anything routine on the assets, apart from checking to see that there's nothing wrong with it. So they're checking. So their maintenance team went from people doing maintenance to people trying to find something wrong with the assets, find something, anything, and if there's any doubt, we'll fix it or we'll replace it, we'll get it off the system. Now that approach, by swinging that operational expenditure over to condition monitoring, brought further reductions. Now obviously it's diminishing returns, it gets harder and harder, but that's a very significant improvement. Using a little bit of technology, same assets though, same assets still there, just again using them differently and using the staff differently. So this is where the staff came in. And finally, they've managed to keep it going. This was not a freak result that they managed to drive down. They've kept it pretty low, unheard of. And this is this prevent philosophy, preventing for anything from happening ever that we didn't expect. That's now deep-rooted in Singapore Power's philosophy. I'll give you an example of how seriously they take this and the implications of going down this route. If an electrical joint fails on the UK system, first priority is get the lights back on. Secondly, go out and fix the cable. Usually, hopefully, a one-joint repair, a few £100, £1,000, get the cable back in service, job done. So if it was a very surprising fault, you might analyse that. You might take that joint away for forensic analysis. I don't know if you do that. Most of the time, it will just get thrown in the skip. If they ever get a joint failure in Singapore Power, obviously the supply is automatically restored. The joint is removed from service. It's taken back to the lab. The joint is opened up. The name tag of the jointer who did that joint is removed from the joint. And the investigation will then continue as to what exactly did he do wrong, and he'll be charged for the repair out of his salary. That's how serious they take this. It's a different world. Now, it's not necessarily a world I want to live in, but it shows how the end-to-end, it's much more than just buying new assets or managing assets better. It's a complete change of philosophy. Yet the result was that there is 100-fold improvement in service here. This is fascinating. I mean, we'd be happy with 10%. And so it shows how by using this very clear objectives and making sure that it impacts on every part of the company, not just operations, how when it all comes together, it took them 20 years, but the step change in what was achieved is beyond anything that I would have thought possible. Similar technology, similar network arrangements, similar assets, they're not using anything too exotic, and I think that's pretty impressive. That's quite an achievement. And I suppose my challenge is, could we do something similar in safety? We're pretty good at safety. But imagine a 100-fold reduction. I don't know if that's even possible. But one thing I am convinced of is that you can only get this level or this scale of change by thinking with this end-to-end system. If there's one thing asset management's taught me is you can't do it alone. You've got to have the whole company behind you and make sure it's everybody's trying to achieve the same thing. So yeah, I mean, there's an example of success. 15 pence a unit and 45 seconds off a year. Just a very quick, superficial example, but nevertheless an important one about how asset management can help achieve the right outcomes if you use the right assets in the right way. So if that's what we want from safety, hopefully us asset managers can start to learn a little bit about what safety culture and bring some of what you're thinking into our decisions and make sure that we're fixing the problems way before they even happen. And perhaps that can produce the kind of change that we want to see. Okay, that's it from me. Thank you very much.